Hello everyone, and welcome to tutorial number 3 of Introduction to Deep Learning. Today we're going to talk about data sets and Dataloader. But first, let me give you some reminders. So please use Piazza for all the communication. So if you have questions, general questions or private questions, please post them there. You can use general questions and public posts, so other students can also see them and can also discuss them. If you have anything which is private, some private concerns, you can also post them on Piazza and mark them as private. In that case, only the tutors and the TAs will gonna see them. That means please do not email us directly on our personal email addresses because we cannot see which have been answered, and it's just too many emails, so we cannot really reply to them efficiently. Another thing is that the office hours already started last week and already few of you have taken part in them. So that's another way for you to get some feedback, or if you have questions you want to discuss with a tutor during these office hours. You can find the schedule on Piazza and you are free to choose any of these. And also the solutions of all the exercises we're gonna post together with the following exercises. The outline of today is that we're gonna quickly talk about the general structure of the exercises. So we're gonna quickly recap the pillars of deep learning, so the basic building blocks and parts of a deep learning pipeline, and also give some motivation about the reason why we want to reinvent like some of these building blocks and not just use one of the big libraries. So, and then we're also obviously going to discuss the contents of the exercise number 3. So to give you a general overview of the exercises, let's start with the so-called pillars of deep learning. So these are basically some separations of such a pipeline, and on the left side you can see that we have a data pillar, and with these deep learning approaches, these are heavily data driven, so data is like the main driving factor and the source of basically the information we want to distill. So usually, and especially for supervised learning, we have some kind of labeled data set with some data samples and their corresponding labels. These can be anything from images to some data points to language text and so on. The second pillar is the model pillar, and that involves all the network part and the optimization or the learning basically. So here we have an element of a network that can be quite abstract, and to basically learn efficiently from the data, we also need to have some kind of loss or objective function which we want to optimize. And the final pillar is everything which is around the solver, and also basically the way how we learn from the data with our network. So that pillar is basically about the optimizer, the training loop, and also some kind of validation to get like some idea how well we actually perform. And just to go back a bit, the model part can be any function basically with some learnable parameters or weights. And also the loss or objective function can be something quite straightforward as, for example, like some distance measurement. Here you can see basically the dark gray elements. These are things and building blocks you can implement once, and these are pretty general purpose, so you can reuse them in basically all of your projects. So for these you only have to do the effort once, and then you can reuse them. For stuff like dataset or network, these are more focused or specific to an individual project or task. So network structures usually can vary quite a lot, and you basically try to find a good one here. And the data set heavily depends, or your implementation of the data set heavily depends on the task and the data you're going to use. So the task of the 3 upcoming exercises is actually to, as I said, reinvent the wheel. So for that, we're going to implement some of these basic building blocks in NumPy and don't directly use like PyTorch or so. So these going to cover the data set and a Dataloader block in today's exercise. And next week, we will have a look at the solve and a simple task, which we're going to try to solve. And in exercise 5, you're going to implement your first neural network yourself. So these 3 exercises are basically, major building blocks. And with that, by implementing yourself, you can get like a hands-on experience and basically know the moving parts. All right, so let's move on to the content of this exercise. And as I said, today we're going to cover the data set and the data loader. So these are 2 ways to abstract the access and to your data, and also to efficiently load the data during training. So for that, we're going to have basically 2 classes. One is the data set and one is the data loader. The task of the data set is to provide easy access to your raw data and also to perform some pre-processing. So as I said, concretely, the data set should read individual samples from disk and provide an easy interface to the data. And it should also perform, or it can perform, simple on-the-fly data pre-processing. So for example, if you have scraped images from the internet, these usually come in all different kinds of sizes. So one way of this on-the-fly pre-processing is to scale them to a fixed size during data loading. Another thing the data set can do is, for example, augmentations. So if you don't have enough data or you just want to increase the amount of data, you can perform some augmentations on the fly, which are usually pretty cheap. So these are things, for example, you can randomly flip your image horizontally. You can also take different crops within your image and basically augment the amount of data you have artificially. And these are like the 2 main parts of the data set. Here's an example of an image classification dataset structure. So to give you a more concrete example about such a sample dataset, you can give it a path to a folder, which you're also going to see during the exercise. And this folder has like 10 subfolders. So you can see this folder, dataset folder, has like some folders called bird, cat, car, and so on. And each of these folders gonna contain a specific amount of images of that category. So obviously you can see like in the cat folder, you're gonna have images of cats. In the bird folder, you have birds, and in the car folder, you have cars. And so if you're gonna initialize your image dataset with a given path, then it should read the structure of the folders. So parse all the file names, and with that you basically get a list of all the files together with their label. So you get a bunch of file names, and this label here means like the specific class ID. So for example, cat gonna have like some class ID of 1, and a plain class gonna have the class ID of 10. When you initialize this class, usually it only reads the file names, but does not really open or reads the images, because that would consume quite a lot of memory. And what it also does is that it defines like this mapping between class IDs and class labels, what I just described. So basically 1 maps to cat and 10 maps to plain, for example. And if you then actually call this class by trying to iterate over it or by giving it an index, this function then actually reads the raw data from disk. So these gonna then read images of one specific image from disk. It can perform some on-the-fly preprocessing, as we described earlier, and also optionally create some augmentations. Here's another visualization of this pipeline, so to say. So again, on the left side, we have our folders of categories. Then if you call the dataset class or initialize the dataset class, it reads the file names and assigns it a label. And if you then access a specific element, you will get a single sample with like the actual image and also like a mapped class ID. So two things about some details about the dataset thing is that we excluded or abstracted away some low-level scripting, so you don't have to deal with like operating system calls. So yeah, you don't have to deal with that. Another thing I wanted to mention is previously I said usually you don't want to read everything into memory at once, because usually if you have big data sets, these won't fit into memory. However, if you have small data sets and they actually fit into memory, that can give you a huge performance boost basically in terms of loading time, because you only have to load the samples once and then they're into memory, and then you can only need to access the memory, because depending on how much data per sample you actually need to load, this can be quite slow and drive down your training time. If you have like a small data set and you know that you have enough memory, you can try to load everything into memory and have much faster training times. The second part of this exercise is about the data loader. So that's the second part, and this basically defines the way how we load it from the data set and prepare the data more specifically for our training. So here we can define things as the number of images per batch. So that's going to be covered in the lecture, this mini batching. And also, for example, the number of workers or processors, because some of the tasks we're going to see can be handled in parallel. And another thing is that the data loader also shuffles the data set, because when we load the images folder by folder, they're going to be ordered. And usually you don't want to have like such a strong order, because then you would first, like your network would first only see like cats for 5,000 images, and then in the next 5,000 images it only going to see cars, which gonna make the training quite bad. So instead we want to shuffle the data and have like a mix of images. And another step in detail is that the data loader basically splits the data set into small subsets, so-called mini batches. So down here you can see an illustration of how the data loader and the data set go hand in hand. The data loader actually only uses list of indices to index into the data set. So it does not really work directly on the data, but only works on top of the data set. So for example, the data loader here has like some list of indices with the same number of samples you have in the data set. And then in the first step, it usually shuffles these indices, and then it's gonna split them into mini batches. And when you then basically iterate over or use the data loader to iterate over your data set, it calls the data set to then actually get the actual data. We're going to see this in more detail on the next slide. So the first thing is it's more about implementation detail about Python and how we want to implement it also in our way is that the data loader is an iterator and not a list. So that's an implementation detail. But one thing you cannot do with an iterator is that you can not directly access the data with an index. So you cannot call data loader with a given index. But instead you have to use this next function to iterate over the data set and to get the next element. So if you call next data loader, then you would actually get back some data. And also some Python specifics about these called iterators is that the iter function uses yield instead of return. You're going to see this if you go through the notebook and the code, but just to give you some hint and some heads up that the iter function uses like this yield command. And what you want to get from the data loader is a mini batch in a batched format. And if you're going to play this through, again, a bit in more detail. So the first thing the data loader has is like this list of indices, which correspond to the elements in your data set. So if you have a data set of 50,000 images, we have a list of indices going from 0 actually to 50,000. And in the first step, we're going to shuffle this list and have arbitrary numbers in the list. And then we're going to split them into mini batches, which can be defined like basically how many images or samples you want per batch, basically to split them into small subsets. And now what the data loader does is if you call next, you have like basically a pointer pointing to the current location in your data loader. And if you call next, the data loader will access the dataset class at these specific indices. So it's going to call, for example, dataset 17 and 132, and will get back like the loaded data from disk. So it gets the images together with the label. And this part, for example, can be done in parallel because these are two independent steps. And a final step is that we want to get back the data in a stacked format or in a batched format. So here we have a list of 2 elements, but what we actually want to do to pre-process it or process it with the model in more detail is that we want to have like this batched format. So we want to stack together the images and also the labels. So that's basically also how PyTorch handles like dataset and data loading. And since we want to stick close to how PyTorch does it, that's basically the pipeline. And after you called the next function, the pointer to the current location goes to the next element. And if you call next again, it goes on and on. And with that, you can basically loop over your data set using the data loader. So the data set and the data loader are the 2 parts you're going to implement in this exercise. And for that, you're going to have 2 notebooks. One is for the data set, and here we're going to use the Cypher 10 dataset, which is like a pretty common image dataset. And also as I described, you're going to implement the data loader in more detail. So about the implementation and the submission. So you implement the solution in both these notebooks. And at the end of the second notebook, the data loader notebook, you're going to create a single submission zip, which you're going to then upload to the submission system. So you have 2 notebooks, but only 1 zip file, which you're then going to upload. Good luck with the exercise, and if you have any questions, please post them on Piazza. And with that, see you next week.